Okay, class, for this one, we're going to continue working with this sheet. What F value from the table do you need? I'm going to do number 2, item number 2. You've been asked to compare 4 groups simultaneously via an F-test and test the null hypothesis at the 0.01 level. Okay, so 4 groups, so that means K equals 4. And we've been asked to test the null hypothesis at the 0.01 level. Let's figure out n sub tot as well. N sub tot, again, is simply the total number of cases involved in our analysis. According to this information on number 2, n sub 1 equals 6, n sub 2 equals 5, n sub 3 equals 7, and n sub 4 equals 5. So group 1 has 6 cases, group 2 has 5 cases, group 3 has 7 cases, and group 4 has 5 cases. So that kind of also answers the question, by the way, of whether or not you have to have equal number of cases in each group. You do not. In addition, you don't have to do anything special or different, which was not the case with t-test for 2 samples. You remember? If you had to calculate the standard error for the difference, it was much nicer, much easier if you didn't have, or if your 2 samples were of equal size. With ANOVA, the formula actually accounts for that automatically, so you don't have to worry about whether or not there's nothing different that you need to do if you have a differing number of cases in each of your groups. So here we've got 4 groups, so K equals 4. And we have group 1 has 6 cases, group 2 has 5 cases, group 3 has 7 cases, group 4 has 5 cases. So for n sub tot, we just need to add those together. 6 plus 5 is 11. 11 plus 7 is 18. 18 plus 5 is 23. So n sub tot equals 23. So now that we know K, which is 4, K equals 4, and now that we know n sub tot equals 23, then we can figure out the degrees of freedom for each. Degrees of freedom between or / treat equals K minus 1. And again, I can do that in my head. K minus 1 is 4 minus 1, or 3. And then degrees of freedom within / error equals n sub tot minus K, or in this case 23 minus 4, or 19. So degrees of freedom numerator 3, degrees of freedom denominator 19. Let's turn to the table. Degrees of freedom numerator 3, that means the F value is going to come from the column labeled 3. 4 minus 1 is 3. K minus 1 is 4 minus 1, or 3. And then degrees of freedom denominator is going to be 19. N sub tot minus K, 23 minus K is 23 minus 4, or 19. So the column is 3, the row is 19. Oh, the last thing we need to know is the 0.01 level, or the level at which we're testing the hypothesis. In this case, we were asked to test it at the 0.01 level. So I'm looking at what I think is the correct coordinates and the boldface, and I see an F value of 5.01. That is our critical F value. That is the F value from the table, 5.01. More specifically, let's state what that number means. That is the maximum amount of between group variance we could expect to occur by chance alone given certain conditions. What are those conditions? The number of groups that we're comparing, in this case 4, degrees of freedom 3, and the total number of cases in our analysis, and the 0.01 level of significance.